So the first question, we are going to do question 3. So the question reads, a constant force of F pulls a 50 kilogram block. Now, step number 1, sometimes in grade 12, they will not only give you the mass as 50 kilograms, they might give you the mass in grams. But now remember, we have to use conversion factors in order to go back to kilograms. For an example, if you climb onto a scale, you want to check what's your weight and all that stuff, the scale doesn't really give you in grams, we use kilograms. So it's the same thing in physics. We have to use a constant SI unit, which is kilograms. So in grade 12, they might spice it up by giving you the mass, but giving you the mass in grams. So step number 1, you'd first have to convert the mass from grams to kilograms. It's not wrong, but we need to be consistent. Remember, the examiner wants to see that you remember that the correct SI unit for mass is in grams. So it pulls a 50 kilogram block at a constant speed over a rough horizontal surface. I just want to go to constant speed as well. In grade 12, they also like saying something has a constant velocity. Now remember, if velocity is constant, then there is no acceleration. So for example, if we were to use F net, which is equal to ma, it means that my acceleration will then be 0. So that's one of the tricks that they might give you. They might tell you something is being pulled, but at a constant velocity, which means your acceleration is 0. The examiner wants to see that you've paid attention in grade 10 to know that when velocity is constant, there's no change in velocity, meaning there's no acceleration. Remember, if velocity changes, then we've got final velocity, initial velocity, we are able to find acceleration. But if that is then constant, then acceleration does not exist. That's another key point. And it's over a rough horizontal surface, which is AB. They've given us the length. In grade 12, they can actually give you the distance of it or ask you to even calculate it. And this is shown in the diagram below. The coefficient of kinetic friction. Now, coefficient is just the ratio of kinetic friction. So this is how we use the ratio. We call it the coefficient. It doesn't have an SI unit. But now, taking you back, coefficient, this is also called mute. It's also used as a conversion factor. So this is the diagram that we have. Just want to remove all from the diagram. Let's scrutinize the diagram. Talking about Newton's laws, we have to talk about forces. So I know that we're going to have a normal force on this side. I can already see that this ground is lumpy. I'm given the coefficient of kinetic friction, so it means I'm going to have friction in that direction, and I know I'm going to have in the opposite direction of f of n must then be f of g. Something also to add. Now you must remember this. If something is being pulled at an angle, we have to break up the forces according to its components. So for an example, you can take this as a resultant, not really as, but for you to understand. So if I've got f of y in that direction and I've got f of x, this one here is then the force that is applied. But me calculating f, because f would be unknown or whatever, you have to take into consideration f of y or f of x. Where does this come from? Where does this come from? Remember, if something is on an incline and there is gravitational force that is pulling it down, we can break it up into its components, which is Fg perpendicular and Fg parallel. It's exactly the same thing. If we are pulling something at an angle, then we have to take into consideration f of y and f of x, which means, I just want to scan through this one, I can already see there's f of n going up, there's also f of y going up, so I must take that into consideration. Going back to vectors in grade 10, if we have two forces in the same direction, it means then we need to add those two forces. So can you see how we are mixing grade 10, grade 11, and then coming back to grade 12? So now we have scrutinized our diagram. Now let's see what the questions are asking. So 3.1 says, draw a labeled free body diagram showing all the forces. Now, my darlings, in grade 11, we are taught about a free body diagram and we are taught about a force diagram. There's a big difference between the two. When we talk about a force diagram, we use a block. When we talk about a free body diagram, the object is represented by then a circle or a dot. So do not make that mistake. If they say free body diagram, we use a dot. If they say force diagram, then we use a block. But most of the time, force diagram is in grade 11. So they want us to draw a labeled free body diagram showing all the forces acting on the block. Now, key point is, for a free body diagram, if the question is for 4 marks, it means I have to have 4 forces. Now, another thing to remember, this is on a horizontal surface. We have to show the dot that's on a horizontal surface. If it was on an incline, just want to draw the dots. Let's say we have all the forces like that. Then you can remove this, and this shows that it's on an incline. This shows it's on an incline. Something on a horizontal surface is on a horizontal surface. This and this is not the same thing. You need to show the examiner that you understand something is on an incline. So let's answer question 3.1, where they say we must draw all the forces. Remember, it is for 4 marks. They said a free body diagram, which is a dot. Now I know we have F of n that is going up. I know I also have F of g, so you can say the force of gravity, or you can say the weight. They said there's a coefficient of kinetic friction, which means I'm going to have Fk. Now remember, Fk, kinetic friction. Fs is static friction. You must read the question accordingly, and then you'll know what the examiner is looking for. Now remember, I'm going to draw it wrong, and then I'm going to draw it right. They are pulling this block. They're not pulling it in that direction. They are pulling it at an angle. So you must show that your force is being at an angle, because this means they're pulling it horizontally straight, which is not incorrect. Which is incorrect. I'm going to show it at an angle by putting it at an angle like this and saying that is then my F, or my F applied. That's what the examiner is looking for. So 1, 2, 3, 4 forces. Each force counts for a mark. Let's look at the next question. So 3.2 says we must state Newton's first law of motion in words. Now, how I always tell my kids, I always have a story behind everything and how I remember things. Or always try to find, if you see the formula or you understand what Newton's trying to say, think of something practical in your life so that you can actually link it to and say, oh, I'm linking it to that, so that you can remember it like that. It always works for me. If I think of Newton's first law, I always think about a pencil on the dashboard of a car. If you're driving and you're cruising in your car and all of a sudden a dog parks and you put on the brakes, the pencil will move forward. So an object will remain at rest or continue to move unless acted upon by an external or resultant force. Then it only moves. If you're still cruising, you don't have to brake, then the pencil will continue to remain at rest until you put the brakes on, right? That is Newton's first law. Newton's second law. If me and Bali are pushing a box and we're applying a force and all that stuff, we're pushing the box forward, it's very unlikely that the box will move to the side. So which means a force applied on an object, the object will accelerate in the direction of the force, meaning that acceleration is directly proportional to the force and then inversely proportional to the mass of that object. And then Newton's third law, think of people doing the tango, right? They are moving. For people to actually dance with each other, I'm applying a force on somebody, and somebody must apply an equal but opposite force to me, and that is the only way we can then salsa. That's what Newton says. If object A exerts a force on object B will exert an equal but opposite force to object A. So think about those stories. So now let's state. So they're saying state Newton's first law of motion in words, and this is only for 2 marks. Now remember, if you have to state something, have to define something, it does not change. If you have to explain something, it's your own discretion. So with 3.2, we say a body will remain in its state of rest or motion at constant velocity unless a non-zero resultant or net force acts on it. So now you can, maybe in a memorandum, there might be 2 or 3 ways in which you can say it. You can find the easiest one for you to remember, and then you might get it right. Just to give you guys a tip on what I do with my children in my class, I have a little booklet for them with all the different types of definitions. So as you're moving along, you read your definitions, because remember guys, how I always say, you cannot fail because you were lazy to read. You do get marks for definitions, and sometimes these marks for these definitions can be up to 3 marks. Now, As you can see the trend in your question papers, for every time there's a new question, there's always a define this, explain this, or whose law, or the phenomena, and so forth. So you must make sure that you know all your definitions, you know all your principles, your laws, and your phenomena. You cannot fail because you are lazy to read. They do count marks, and it's really easy marks. And the nice thing about it, that it does not change. So let's make it a habit that we get all our definitions correct. Let's look at another question. So the next question, we start calculating. I just want to go down a little bit. We start calculating, and they say we must calculate the magnitude of f. Let's just go back to my diagram. Now I know that they're looking for f, which is my f applied, but remember, we have to take into consideration all the other forces that are actually working on the f. So let's see how we're going to calculate that one. Just go to a new slide. So that is 3.3. We want to calculate f. Now remember, I'm going to say f net is equal to ma. Now remember, what is then working on the f? We have to take the f of y. Just want to go back to this one. We have to take the f of y into consideration. We also have to take the frictional force into consideration. I've got a vector in that direction. I've got another one in this direction. They're vectors in opposite directions. So let's take that into consideration. Let's calculate for f. So then I can say, remember, if we're working with y, with x, then we use cos. So I can then say f cos theta minus my fk, which is my kinetic friction, is equal to 0. Then I can say my f cos of theta is equal. Now I just want to take this, I want to branch this off here. Remember, if you're looking for fk, the formula is the coefficient of kinetic friction, and then we have n. So I'm just going to take this part here, and I'm going to substitute it here because it is exactly the same thing. If you do want, you can work it out on the side, or you can just bring it in together. I'm just going to do everything in one equation, gives you 0. So now let's calculate what we have. If I say f, my diagram, I have cos of my theta is 20 minus, now I'm going to put that as it is there. I'm going to say, if my n there, I'm going to say the coefficient of kinetic friction, and n gives me 0. Let me just calculate what is cos of 20. Cos of 20 gives me 0.94. I'm going to take it to 2 decimal places. The number after the 3 is a 9, and if the number is 5 or greater, it will change the next number into a 4. So here I'm going to have 0.94. I still don't know what f is, minus. Now they gave me the coefficient of kinetic friction, which is 0.4. Now, if I'm then looking for my normal force, I'm going to do my normal force over here. This is where I got it. So now remember, if you've got Fg, which is your normal force, I'm just going to say f of n, plus f sine theta. Where do I get that? Remember, if we have vectors in the same direction, I've got my f of n, which is going in that direction. I've got my f of y also in the same direction. So I need to take these two forces into consideration. Vectors in the same direction. From grade 10, we know we have to add the forces. Now, mg I can calculate as mg, or f of g is mg, is equal to f of n plus f sine, and this is sine of 20. The mass of the block is 50. Gravitational acceleration is 9.8, is equal to f of n plus, let's find what is sine of 20. Sine of 20, that gives me 0.34. The 2 is less than 5, so it does not change the 4 into a 5. So I'm then therefore going to have 0.34, and I still don't know f. If I want to make f of n the subject of the formula, I'm going to say f of n. I'm just going to take this to that side. So I'm going to have 50. I'm going to have 9.8. If anything jumps the equation sign, the sign will change from a positive to a negative. That is 0.34 and then f. So let's see how much I get there. Let's work that part out. Just move that. So I'm going to say 50 multiplied by 9.8. It's going to give me 490. I'm going to write everything. So f of n is equal to 490 minus 0.34 and then F. Remember, I still don't have F. So now what I can do is where I see the normal force, I can substitute it with this entire equation here. So I'm going to say 0.94, and that is of F minus 0.4. Now, F of n is the 490 minus 0.34, and F is all equal to 0. Now, in this case, the only difficult thing was for you to find your f of n, working that with your f of y, because it's both unknown and we have the force that's unknown. Now, this step is all just about mathematics. So let's work that out. So the one thing to do, we are going to multiply everything inside the bracket. So remember, if they are touching, it means multiplication. We're going to multiply inside the bracket, and then we're going to solve all our f's. So I'm going to have 0.94f minus, and this side I'm going to have 490 multiplied by 0.4. I'm going to get 196. 196, a negative times a negative is going to give me a positive. Let's take this there. I'm going to have 0.4 multiplied by 0.34, which is going to give me 0.136, 0.136, and remember you still have your f is all equal to 0. Now I can move all my f's to one side. Let's just leave it on the side. I'm going to have 0.94 on this side plus it's f plus 0.136 is all equal to, this number will jump the equation sign. Something jumps the equation sign, turns into a positive. This will be 196. Now let's see what we get here. So I've got 0.36. I must add 0.94. 94. That is going to give me 0.076. Wait, it's 1.076. 1.076. 1.076. Just not forget my f on this side. 196. Now, I want to get my f by itself. To get f alone, I'm going to divide both sides by 1.076. On both sides, 76. This and this will cancel, leaving me with only my f. Let's see what I get. So I'm going to say 196 divided by 1.076. And that's going to give me, I get 182.15. The number after the 5 is a 6, which means it's 5 or greater. It's going to change my 5 into a 6. Remember to always leave your final answer in decimal places, in 2 decimal places. 182.1517. There we are. Just write that as 17. Now remember, the examiner wants to see that you understand that the SI unit for force, or the unit in which we measure force, is then newtons. So we do get this answer in newtons. So this means, going back to our diagram here, our F applied will then be 182.156. This was actually for 6 marks. So for 6 marks, you can see that we did a lot of work. We first had to find the kinetic friction, then we had to make sure that we understand that Fg and F of n and F of y must all be taken into consideration when working out F of n. And with that, we didn't know the F applied, but we used the F of n. We substituted it back into this equation, and then we were able to find the value of F. Let's see our next question. So we are doing 3.4 now. Now they want us to calculate the normal force, and this is only for 2 marks. We just erase everything off here. Remember, the normal force is the one perpendicular to the surface, and it's moving up. So if I had to look at my normal force, this will be the force that is moving up. But now remember, when you talk about the F of n, we must take into consideration my F of y. In the opposite direction of that, I've got my F of G. So always take that into consideration. So for 2 marks, let's calculate our F of n. So this is for 3.4. So for my normal force, I can then say my Fg. So now, the easiest way in which you can do it, remember, we found F of n as this. We said, oh, this was F of n. Now that we know F, we can actually substitute F here in order to find F of n. I'm going to do it the long way around in case you still don't understand me. But what I'm saying, before we had to just find a substitute for F of n. So I already have this one here. I can just substitute it here. That is why it's only for 2 marks, because you've done most of the work in question 1. Unless or in case you still don't understand me, I'm going to do it the long way around. So I'm just repeating myself and we make sure that you actually have it. So let's do it the long way around. I know that FG is going to be my f of n plus, in the same direction, I've got my f of y, which is f sine theta. Now my f of g is my mass of the object times gravitational acceleration. My f of n, we just keep it as f of n, plus f sine, my angle, is the sine of 20. The object has a mass of 50. Gravitational acceleration is 9.8. I am looking for f of n plus. Now I'm going to say sine of theta. I'm taking it back from the previous one. We had 0.34, and that was just f. I'm still looking for f of n. I'm going to make f of n the subject of the formula. I'm going to remove it, take it on that side. I'm going to say f of n. I'm going to have the 50 multiplied by the 9.8. If something jumps the equation sign, it becomes a negative. Negative. If it is a positive, it becomes a negative. If it was a negative, it will be a positive. Minus 0.34, and we still have f. Now remember, taking it back from the previous slide, we got 490 on this one, minus 0.34. We just calculated f in the previous equation. We got 182,156. Now this is just pure mathematics. So now remember, according to BODMAS, we must first multiply before we can subtract. So I'm going to multiply into the bracket first. Make sure you first do BODMAS, or you can put the whole thing in your equation, in your calculator. So we're going to have 0.34 multiplied by 182.1. Let's make it 5616. See what we get there. So I get 61.9. I'm going to write everything 9334 and then only round off my final answer. So I'm going to get 490 minus 61. Ooh, I actually forgot 619334. 619334. Now I can subtract the two. BODMAS says after you've multiplied, you can then subtract. So I can say 490 subtract 61.9334. Let's see what my value for f of n is. I get 4.280606. Now, the 6 is 5 or greater, which means I can round off with this 6 into a 7. And now it is in 2 decimal places. So f of n will be 428,07. The examiner wants to know if you know the SI unit we use to measure force, and that is in newtons. Key point, what they said, please state Newton's first law first. That is then how we knew that we are talking about Newton's laws. Number 3.5, also now for 2 marks, they want us to calculate the frictional force. Now remember, they have given us the coefficient. They've given us the coefficient between the two, which was the 0.4 that we've been using. So I just want to go back to this first slide. Most of the work was already done here. This is where we first found the formula and then plugged in. But now we actually have to find the f of k. So let's go back to this equation. Let me do it here. So we have 3.5. So the equation is f of k is equal to the coefficient of kinetic friction and then your normal force. So let's see. They're looking for f of k. My coefficient was given to me as 0.4. We got that on our question paper. We just calculated f of n, which is this one, and then we get this answer here. So we're gonna plug in the 428.07. I just want to tell you guys something quickly. For an example, let's say somehow, somewhere you had a sneeze and then you got the wrong answer because you didn't punch in so correctly in your calculator. You must make sure that you continue to use the answer that you got for your normal force and plug it into the correct formula moving forward. The examiner wants to see that, okay, even though you didn't get the right answer for your normal force, but you can actually have continuous assessment, mean a positive marking when they are looking at 3.5, because this means you understood that the normal force that you got in 3.4 is the same normal force that we're going to use in 3.5, because it's the same block. But now if you go ahead and you go use a different one or you guess it, then the examiner can see that you probably just guessed the answer anyways. So make sure that if your answers are following each other like this, like how this question paper is going, you continue to use the answer you got previously and you use it where necessary moving forward into the next equation. So now let's calculate that so we can find our kinetic friction. I can therefore say 428.07 multiplied with the coefficient of kinetic friction, which is 0.4. Let me see what that gives me. I want it as a decimal. This gives me as 171.228. The 8 is 5 or greater, which means it will convert the 2 into a 3. So we're rounding it off to 2 decimal places. So I will get 171.23. Now remember, the coefficient of kinetic friction does not have a unit because it is a ratio, but kinetic friction does have, and we still use newtons. Let's look at another question. So now the question here is saying the same constant force, so this remains the same, is now applied to the block over the same rough horizontal surface as below, but the direction below changes. So remember, before we were actually pulling the block up with F applied, taking into consideration my F of y and my F of x. But now I'm actually pushing the block down, and it's going to move in the direction of motion. But now remember, I want you to think of something like this, how I can use these two examples. If we are applying a force down, think of you sweeping the floor. You are sweeping the broom and you're holding on the broom and you're sweeping the floor. Or you are trying to pull something up, right? If you are pushing it, you are applying a force, but we have to take into consideration the components of that force. If you are pulling it up, we also have to take into consideration those types of forces. The one thing that we can see here is that if they are both going up, we know that the normal force will be in the same direction. In this side, the normal force will be in the opposite direction as to it, but it will be in the same direction as Fg for gravity. So which means if we are looking at this one, the normal force will increase, therefore increasing the frictional force. So what do they say? They want us to give a reason why the block will then move slower than below, and this is for 2 marks. The way you need to answer this question, take into consideration f of n. We have f of g in the opposite direction. If f of n is, we are pulling it, they are in the same direction. If we are pushing it down, it's in the same direction as f of g. F of y is still in the direction of motion. So this is how I would have answered it, and this was 3.6. Now we know that pulling it down, the normal force increases. The normal force increases. And you can say therefore or hence. Let's use hence. It's exactly the same as therefore, hence the frictional force. Hence the frictional force. Hence frictional force increases, which makes it harder. Making it harder to move the object forward, to move the object forward.